All right, so welcome back. So we are live right now. So welcome back to this amazing platform of Tutee Learning, and let us discuss about the concepts of planes, right? So if you are new to this particular platform, I would request you to please watch the previous lectures, okay, before you come to watch this following content, okay? Because we have started with discussing about first with vector algebra, and then we discussed about three-dimensional geometry. So this particular lecture is going to be on the concepts of planes and a straight line, the similar concept that we were discussing in the previous class, right? So if you haven't watched the previous class, please go back to the playlist and check out the previous lectures, right? So as of the previous lecture, we have seen these following concepts. All right, so we have tried to explore these following concepts in our previous discussion. So with this, let us start today with our today's discussion, and that is going to be on the concept of projection of line on a plane. So as promised, like while I was discussing about the last day's problems, I said that there might be also a question whether line does not intersect on the plane. However, in that case, you might be asked to find out the projection of that particular line onto the plane. So what if you project that particular line on the plane? What will be the final projection of that particular line on the plane? Okay, so let us try to understand and try to solve those particular problems. I hope you are all ready to start with this. Okay, so let's start. So as in today's lecture, we'll discuss with the concept of projection of a line on the plane. Okay, of a line on a plane. So we will discuss about this particular concept of projection of line. So what is actually meant by the projection of line, or what is the question, or what is the uh, expectation of this question, right? Let us try to understand that. So let us say the question will be defined something like you will be given some line equation. Let us say this is some line L. Now the line equation will be known to you. So let me write the equation of this line. So this equation of line will be given something like x minus x1 by a is equals to y minus y1 upon b will be equals to z minus z1 upon c. So this will be the equation of line that will be already known to you. Now once you already know the equation of the line, and they will also give you the equation of the plane. So let us consider this as my plane. So they will also give you, along with the equation of line, they will also give you the equation of this plane. Let us call this plane as P, and the equation of this plane will be given something like, let us say, alpha x plus beta y plus gamma z plus d equals to 0. Okay, plus d is equals to 0. Let us say this is my equation of the plane. So I have both the equation of the line and the equation of the plane. Now the question is asking you that try to find out the projection of this line on the plane. So how am I going to do that? So in order to find the projection of line on the plane, that means it will be a line. Or the same question can be asked as try to find out the image, or try to find out the image of this particular line about this plane. So this is something like that of the concept of image. Okay, so instead of giving you a point, it is asking you to find the image of the line about the plane, or when you reflect about the plane. How do I solve those questions? So in order to understand the solution of those questions, let me draw the plane properly. I think it's not visible on the black screen. Yes, so this is the plane. So just a diagrammatic representation. Okay, now as we have this following equation of the plane, so from this following equation of the plane, and in order to find out the image or the projection of this line on the plane, the simple concept is, let me take some 2 points. Let me take some point and let us call that points as point A and point B. So let me take 2 points on the line and let me try to find out the foot of perpendicular. Okay, the foot of perpendicular of those points on the plane. So let us call this point as A dash and this point as B dash. Then if I find out this A dash B dash which is lying on the plane, then by having the coordinate of two equations, so let us call two sides or 2 points x1 y1 z1 and the x2 y2 and z2, let us call these as the coordinates of the foot of perpendicular of these line points on the plane. Then by joining these 2 points, I'm going to obtain the equation of the line that is lying on the plane, right? Similarly, if I have this point A and I try to find out the mirror image of point A with respect to this plane, let us say that is coming at A double dash, and similarly the mirror image of point B with respect to this plane is coming as B double dash. So if I write this following lines as follows, then by joining this A double dash and B double dash, I can also obtain my image line, okay, or the image of a line about the plane. I hope this concept is clear to all of you. Okay, I hope this concept is clear, right? So let us try to solve or see some questions relating to this particular condition. Okay, is this part clear to all of you? So let us try to solve some problem and then we'll try to introduce you the idea of family of planes. Okay, so before that, let me first take some problems, and if you still have any question in this particular topic, please let me know, or else we can proceed with our discussion on problems. Okay, so let me take out some interesting problems, and that which I think are very fundamental and yet and important problems for all of you, right? So here we start with our first problem. So this is the first problem that you can see over here. So I have taken this problem from this reference source. Okay, so let us try to see or try to solve this problem. Okay, now before I try to discuss a solution, I want all of you to please give a try and try to see whether you are able to get to the right answer or not. Okay, please let me know what all options you are getting as the right answer. Okay, so please try to solve this problem. I don't think that this question is a very difficult problem. This is a very simple and straightforward problem, yet a very basic and fundamental problem, right? So it is very important to solve these kinds of problems in order to understand the theory aspects in a better way. Okay, so please try to solve this problem. So if you read through this question, it is said that you have to find the value of k such that this particular is the equation of the line is perpendicular to the normal vector, to the normal to the plane. So it is very simple problem, right? Now we have seen that in the formulation of equation of plane, we have seen this part up in our formulation of equation of plane. So what we have seen is that the equation of plane is given as r vector times n vector is equals to some constant, and we call that as d. So this is what we have seen in the equation of the line in the vector form. So over here the same thing is given. It is given something like r vector dot with 2i cap plus 3j cap plus 4k cap, and that is equals to 0, right? So from here you can easily compare and say that this is my normal vector. Okay, so from here you will obtain your normal vector as 2i cap plus 3j cap plus 4k cap, right? This is your normal vector. Now, and you have to find out the value of k for which the following line will be perpendicular. So if you have this line, now the direction vector or the vector which is pointing towards the direction of the line is given by the direction ratios, which is given as 2 comma 3 comma k, right? 2 comma 3 comma k, and it is said that these two lines are perpendicular. So let us call this as by some vector L. Now if these two lines are perpendicular, then or these two vectors are perpendicular, then I must have their dot product to be equal to 0. So if I solve for the dot product to be equal to 0, what I will get? I will get 4 plus 9 plus 4 times of k, that will be equal to 0. So on solving this part, we'll come to the final answer of the value of k, that is coming out as minus 13 upon 9. Oh sorry, 13 upon 4. Minus 13 upon 4 is going to be the correct answer. Right? So with this, you can see option number A is going to be the right answer. Very simple, straightforward, right? Where we have applied the concept of vector algebra. Is this part clear to all of you? Is this part clear? Is this part clear? Is this part clear to all of you? Is this part clear to all of you? Please let me know if you have any questions, any confusion. All right. Very straightforward problem, right? So let me give you another problem where you can apply the concept of a line and a point and plane in one particular problem, right? So this is a very useful problem and a fundamental problem. Okay, so you have to find out. So this problem talks about that. So let me show you the problem. So this is the problem that you have on the screen. So this problem talks about that you have to find out the distance of a point which is given as follows, like minus 1 comma 5, minus 5 comma minus 10, from the point of intersection of the line and the plane, right? So it is asking you the concept of to find out the distance, but first of all you have to find out the other point by solving for the intersection of the line and the plane, right? So it's a very straightforward problem, and I actually want all of you to try this problem. Okay, hostel diaries, yes, more question on this topic, sure. Shaurya, which part you are not able to understand? Which part you are not able to understand? Please let me know. Please try out this problem, everyone. Please try to solve this problem. Please try to solve this problem. Please try to solve this problem. And let me know the live chat, whatever answer you're getting. Okay. Is this clear to all of you? Is this part clear to all of you? Okay. Is this part clear? So I'm waiting for your answers in the live chat. Anyone? Any answers? All right. So let's try to see that how we will solve this problem. Okay. So if we try to understand the problem is a very simple problem where you have to find the distance between 2 points. One of the point is already known to you, that is point P, which is minus 1 comma minus 5 comma minus 10. So sorry. Yeah. Okay. This is the point P, and the plane is given as, the plane equation is given to you as that x minus y plus z is equals to 5. So the other point, the distance of the other, so you have to find a distance of point P to another point which is formed by the intersection of the line and the plane. So let me draw the equation of the line. So the line over here, so the equation of the line is given as x by 2 by x minus 2 by 3 is equals to y minus 1 or y plus 1 is equals to 4 is equals to z minus 2 by 12, right? This is the equation of the line. So in order to find out the point of intersection of this line and the plane, the simple fundamental concept is that let us assume this is some lambda. Let us assume this is some lambda. So any point on the line can be given as 3 lambda plus 2 comma 4 lambda minus 1 comma 12 lambda plus of 2. So any point on the line, any parametric point on the line can be given in terms of lambda like this. Now since this point Q is the intersection of this line and the plane, therefore this point Q will obviously lie on this plane, right? This is the fundamental concept. So if I solve this particular point Q for this plane equation, what I will get? So if you substitute this over here, you will get the following result as 4 lambda minus of 1 plus 12 lambda plus of 2, and that will be equal to 5. So if you solve for it, you'll get the value of lambda. So if you solve for this, you'll get the value of lambda, which will be coming out as, so 11 times lambda, 11 lambda will be equals to 0, right? So the value of lambda should come out as 0, which means that the point Q is given as 2 comma minus 1 comma 2. So very simple problem. So you have known the point Q and you know the point P. Therefore, in order to find out the distance of point PQ, we can easily do that by distance formula. So that is x2 minus x1. I'm not writing the formula. So you can, if you have forgotten the formula, you can take it up. So if you subtract and square it, so this is going to be 3 square plus 4 square plus 12 square. Okay. Now if you solve this expression, you will be coming out the answer to be as 13 units. Okay. So the answer to this particular problem is going to be option number D. That is going to be 13. Okay. So if you solve this problem properly, I think it's not a difficult problem. It's a most simple problem. Okay. Yet another fundamental problems. Okay. Is this part clear to all of you? Is this problem clear? Is this problem clear? Let me know in the live chat. Is this clear or not? Are you all able to get to the final answer as option number D? Are you all able to get to the final answer? So option D will be the final answer, right? Is this clear to all of you? Is this part clear? All right. So I hope this is clear. Let's now move on to another set of problems. And this problem is from the previous year JEE Mains paper. Okay. Some previous year JEE Mains. So maybe you can try out this problem. Again, very simple, fundamental problem, right? So whatever we have learned in the theory, please try to apply those concepts and try to solve these problems. Okay. Another very simple problem. Could you repeat it once again? Okay, so you want me to repeat the last step, right? Okay, fine. See, what I'm doing over here is that, so the question is asking you to find out the distance of 2 points. What are the points? The point is given as, one point is already known to me, that is minus 1 comma minus 5 comma minus 10, and the another point that the question is asking you to find out that point by the intersection of this line that I've drawn with a yellow color and the plane that I've drawn with the blue color. So you have to find out that point of intersection of this line and the plane. So what I'm assuming is that I'm assuming that point Q is that particular point where the line and the plane is intersecting each other. So in order to find out any parametric point on the line or any general point on the line, that can be obtained in terms of this parameter, that is lambda. So what I'm doing is that whatever equation of line I have, I assume that equation of line to be equals to lambda. And by assuming this, I can find out any value of x, y, z in terms of lambda, and that will be, so That will be like, for example, x is over here is 3 lambda plus 2. Similarly, I will obtain y, and similarly I obtain z. Now this x and y, sir, your voice is cracking. Is it fine to all of you? Let me check. So that will be like, for example, x. I don't think the voice is cracking. Please check your internet connection. Okay. Anyway, so by that we can find out the value of x and y and z. Now that x, y, z is any random point on this line. Now to find out the point of intersection, that random point on the line must lie on the plane. So we have to solve for that particular line on the plane for which I will have the intersection with the plane. Is it buffering? But I can see on my live stream it is properly going on. So I have my live stream open over somewhere over here. But that live stream is properly working here. Okay. Okay, great. Anyways, okay, come back. So, and that any parameter point Q will lie on the plane. So what I'm doing, once I obtain this parametric form of Q, I'm solving this particular point because it is going to lie on the plane. So I'm putting that in the equation of the plane. And by solving this particular equation of the plane, I will obtain the so-called value of this parameter lambda. So if you solve that lambda, you will see that lambda will come out to be 0. And that makes our problem or the solution much simpler, that we can easily find out the point Q. And once we get the point Q, the distance between point P and Q is simply obtained by the distance formula over here. Okay, so I hope this is clear to all of you now. So the answer will come out to be 13. Is this clear? Hostel diaries, I have repeated for you. Hostel diaries, I think it is clear now. Okay. Alright, so let's try to solve this problem. I hope you can see the problem on the screen. Please try to solve this problem. Whoever solved this problem, I will take a shout out. Okay. So please solve this problem. Good. Try to solve this problem. Hostel diaries. All of you, please try to solve this problem. Every one of you, please try to solve. Please try to solve this problem. Everyone, please try to solve the problem. What is the answer you are getting? Now, this is a very fundamental problem, another very simple problem, which you all can solve by just a one-step solution, right? What is mentioned is that you already know the equation of the plane. So the equation of the plane is given as 2x minus 4y plus z is equal to 7. That is my equation of the plane, right? This is the equation of the plane. Now, this particular line, which is given by the line, let us say this is given by x minus 4 by 1 is equals to y minus 2 by 1 is equals to z minus some constant k is by 2, right? Now it is said that this particular line lies on this plane. Now the simple way to solve this problem when this line lies on the plane is that, now you already know the direction ratios of the line, right? And the direction ratio of the normal vector of the plane is already known. Now this vector of the line and the normal vector must be perpendicular to each other. So another easy important check is to find out that whether this n dot l is coming to be 0. Okay, that is the concept that we try to use when the line is lying on the plane and it is existing, right? But what you see is that if I take up any fixed point on the line, that is 4 comma 2 comma k, and this point must also lie on the plane, right? So therefore, if I solve for this point on with the plane equation, I will get my value of my k. So the k value, so Mahindra Dhoni C6J has answered is option is 7. K is equal to 7, right? Option A. Very good. Very good. Option A is the correct answer, right? So if you solve for this, you will get the value of k is equals to 7. Okay, this is a pretty straightforward solution. So please try to solve, everyone, and you will definitely get the value of k as 7. Is this part clear to all of you? Is this part clear? Is this part clear? Okay, great. So now let's move forward with some other concepts, especially on the concept of planes. So let me now discuss about another very important concept that is called as family of planes, right? That is a concept of family of planes. Okay, the concept of family of planes. Okay, the concept of family of planes. So what is the concept of family of planes? Now, as in straight lines, we have seen that the family of lines actually means, so in 2D straight lines, so we have seen that if we know the two lines, let us say this is my line 1 and this is line 2 in 2D. Okay, so please note this is a 2D part, right, where I have only the x and the y axis, right? So what I've seen that you can formulate any general equation of the family of the plane passing to the point of intersection, something like this, which can be given as L1 plus lambda times of L2 is equal to 0. So this was the equation of any general equation of the family of lines, right? So in the similar manner, we will try to use this particular fundamental concept and extrapolate it to the case of three-dimensional geometry. So what I'm trying to explain over here is that if I have, let us say, in three-dimensional geometry, instead of a line, if I have two planes, something like this. Okay, so this is a three-dimensional geometry thing. So we have now planes with us. Okay, so we have planes with us. Let us say the equation of the first plane is given by p1 equal to 0, right? Now what do we mean by p1 equal to 0? It is very simple. It is like whatever is present on the left hand side, that ax plus by plus cz plus d is equal to 0. That's what I am writing over here. So p1 denotes this plane 1 operator, and let us denote the equation of the plane 2 as p2 equals to 0. So this is my two equation of the planes. Okay, now if I want to find out any random or a general plane which is passing to this point of intersection, which is passing to this point line of intersection, which is passing to the line of intersection of the plane P1 and P2. So this general plane or family of plane, because I can change the value of lambda to obtain any general set of families of planes, right? So different values of planes can be obtained. So that general family of plane can be given as just by this particular equation, that is P1 plus lambda times of P2 will be equals to 0. So if we use this particular equation, we will obtain the general equation of the family of planes. So by using this concept, the concept is very simple. It is saying that if you need to produce another plane which is passing through the line of intersection of the plane P1 and P2, that equation can be simply given by this following equation. So if you use this particular concept, you can try those questions where you have to find out the equation of the general plane which is passing through the line of intersection of two given planes. So we will try to see problems on that as well, and with this particular concept, I think we are now done with our entire chapter, right? So now let me take some following problems, and tomorrow we are going to come live with a problem solving session that is entirely dedicated towards three-dimensional geometry. TV Gaming, welcome back. I remember you. Yes. Welcome back, TV Gaming. Okay. So now in the tomorrow's class, we'll take some general problems, but to end this particular class, now I would request all of you to please prepare whatever we have covered in this entire discussion of vector algebra and three-dimensional geometry, right? Because in tomorrow's class, when we are going to start with solution of the problems or the JEE Mains previous year problems, we'll see that those concepts, whatever we have learned so far, is going to be very, very helpful in solving those questions. Okay. Let us now end this particular class by solving one problem. So let me give you some problem. Okay. All right. So this is a very interesting problem that is involving the concept of the vector algebra things, right? So, and don't worry about questions. Okay. Tomorrow we are going to extremely solve a lot of problems. Okay. A lot of problems we're going to solve in tomorrow's class. So before I end, I want all of you to please solve this problem and get ready for tomorrow's problem solving sessions. Okay. So in tomorrow's class, we are going to solve all the previous year JEE Mains problem that has been asked so far in the context of vector algebra and three-dimensional geometry. Okay. So please try to take a snapshot of this problem and try to solve this problem on your own. Okay. And in tomorrow's session, we are definitely going to discuss the solutions of those important JEE Mains problems. There are a lot of questions that have been asked in the JEE Mains paper. I'm not going to solve all the problems. I'm going to take up only the important problems and the fundamental problems. Okay. So if you are willing to solve all the problems, then you have to take out this pen and solve it. And if you have any doubt, please mention that question by sharing that problem in the comment section. Okay. So maybe you can comment on that particular video after the live stream is over, and you can comment your question that this particular problem you are having a doubt and you want to discuss those particular problem with me. Okay. So with that particular thing being said, let's now conclude the session over here. And I thank you for your wonderful attention, and I wish you